This presentation is on elements and compounds. Well, there's a term called pure substances, and a pure substance is a substance that has only one type of particle. The word particle sometimes gets us confused because it can go with different things. For example, we have this chunk of gold right here, and this chunk of gold is what's known as an element. And if we were to go down with a microscope to the very, very smallest parts that are still gold, so let's say this is our view of our microscope, we would see a bunch of atoms that are all gold atoms. They would all be very identical, and they would all be arranged in an organized pattern, especially since it's a solid. Well, over here we have what's known as a compound. So right here is a picture of salt, which is sodium chloride. It's pretty chunky. But in this salt, we would look down, and if we looked at that same microscope and we were to see the molecules of salt, we would see a sodium atom and a chlorine atom bonded together. And when we looked around, all of the molecules would be these shapes where they were connected together through, well, in this example, an ionic bond. So again, pure substances will have a particle and an element. That particle is called an atom, and in compounds that particle is called a molecule. Well, the formal definition of an element is a pure substance that cannot be broken down into simpler substances, and each element has a unique set of physical and chemical properties. And this is the same exact periodic table that you get in the classroom. This is the document that houses all of the known elements to this point. And as you can see, we have all the way up to 118, starting at number 1 and moving across in atomic number order. It can be broken down into 3 different types. The first type are metals. Metals are good conductors of thermal and electrical energy. They are malleable, meaning that they can be hammered into shapes, sort of like this piece of copper right here. That's an example of malleable copper because it's like copper foil. And then another property of metals is that it can be ductile or drawn into a wire like this piece of copper down here. So we have our example, one example of metals, which is copper. Another interesting example of a metal is this one, which is mercury, which is a liquid at room temperature. This is the periodic table, and looking at the periodic table, there are a lot of metals. Pretty much all of these are metals. So there are a lot of metals in the periodic table. So that is a huge portion of the periodic table. The next group of elements are called nonmetals. Nonmetals are poor conductors of thermal energy and are poor conductors of electrical energy. We have 2 examples here, and this first one, which is right here, is oxygen, and then the second one, which is neon. So those are both examples of nonmetals. Periodic table, our nonmetals tend to be over here, but don't forget about hydrogen over there. So those are the nonmetals. Metalloids, sometimes called semiconductors, have properties of both metals and nonmetals. We have 2 examples down here, arsenic and antimony. So there's some examples of metalloids. Another famous metalloid would be silicon. It's kind of are all in this one area right here, which is boron, silicon, germanium, arsenic, antimony, tellurium, and then polonium, astatine are also usually included in the metalloids. So just a quick recap, we have the metals, which are mostly these elements. We have the nonmetals, which are mostly these elements. And then finally we have the metalloids, which are these elements. So you can kind of see that there's lots of different sections of the periodic table. Well, compounds are a pure substance composed of two or more elements that are chemically combined. Each compound has a unique set of physical and chemical properties that are different from the properties of the elements that compose it. The elements that form a compound always combine in a specific ratio according to their masses, and compounds can be broken down into simpler substances by chemical changes. Well, I've got some examples here. Again, and I put the different things up on top. So each compound has a set of physical and chemical properties that are different from the properties of the elements that compose it. So here is a very famous compound that you all know, which is salt, which we kind of talked about before. Salt, as you know, is edible. You can eat it, no problem. Well, salt's formula is NaCl. Sodium, which is right here, is a soft metal that you can cut with a butter knife. It also reacts violently in water. Chlorine is a greenish-yellowish gas at room temperature and is poisonous. So we have a very reactive metal with water and a poisonous gas, but when they chemically combine and make salt, it has different properties. So that's what this first one is. Well, this thing about a specific ratio is that salt is always NaCl, meaning one atom of sodium and one atom of chlorine, always to be salt. And compounds can be broken down into simpler substances. So salt can be broken down into sodium and chlorine if it goes through particular chemical changes. Another example just to illustrate these things. So each compound has a set of unique physical and chemical properties that are different from the properties of the elements that compose it. Here we have sugar. Sugar, and this is granular sugar, but a simple sugar is glucose, and glucose is 6 carbon atoms, 12 hydrogen, and 6 oxygen. Well, carbon, as you can see, is a blackish colored solid. Hydrogen's a clear gas, oxygen's a clear gas. Hydrogen and oxygen are both highly flammable, but when they become a compound, C6H12O6, and they equal sugar, well, they are no longer flammable, and they are the glucose that we have in our blood. So that also is what this whole elements form a specific ratio. C6H12O6 is the chemical formula for glucose, and it is always that formula. And this can be broken down into the elements as well. That is a quick lesson on elements and compounds.